In Module 2, Lesson 11, I'm going to multiply decimal fractions with hundredths by multi-digit whole numbers. My problem is 82 and 51 hundredths times 63. I'm going to start by making a quick estimate. 82 and 51 hundredths is about 80, and 63 is about 60. 8 times 6 is 48. Adding on 2 zeros, my product should be about 4,800. Thinking back to Lesson 10, when I multiply using decimals, I'm going to ignore the decimal in my final product until the very end. So I'm going to use the standard algorithm today to multiply 82 and 51 hundredths times 63, but I'm going to picture it as I multiply as 8,251 times 63, ignoring my decimal until the very end. When I write it, I'm going to put my decimal point there just so I remember that I have to put it in at the end, but I'm not going to do anything with it yet. So I'm going to multiply as if I had been multiplying without a decimal point, just like I've been practicing since the beginning of Module 2. 3 times 1 is 3, 3 times 5 is 15, 3 times 2 is 6, plus 1 is 7, 3 times 8 is 24. I'm done with my ones digit, so I'm going to put a placeholder. 6 times 1 is 6, 6 times 5 is 30, 6 times 2 is 12, plus 3 more is 15, and 6 times 8 is 48, plus 1 is 49. When I'm finished multiplying, I'm going to add my partial products. 3, 11, 8, 9, 11, 5. Now I have my final answer, but remember I need to add in my decimal point. In my first factor, I was working with hundredths. So in my product, I need to account for those hundredths. So I'm going to look back up at my factor. 1, 2 places in, so 1, 2 places in. I'm going to place my decimal point in the hundredths place so I can see in my final product I don't have 519,813. I have 5,198 and 13 hundredths. I'm going to go ahead and put that up with my equation. 5,198 and 13 hundredths. I'm going to check to see if my answer is reasonable, and I see that it is reasonable because 5,198 is close to 4,800. I could have solved this problem using an area model, and I would expand my numbers just as I have been practicing in previous lessons. Today, I'm going to just show the standard algorithm. So 82 and 51 hundredths times 63 is 5,198 and 13 hundredths. That's all for Lesson 11.